Hello, welcome to my video. In this video, we will be looking at LeetCode problem 1573, the number of ways to split a string. So the problem description says we're given a binary string that is a string consisting only of zeros and ones, and we want to split the string into 3 substrings such that concatenating each substring gets us back to our original string. And we want to return the number of ways that we can create these substrings such that the number of 1 characters in each substring is equal. And it says the answer might be large, so we want to return it mod 10 to the 9th plus 7. So let's take a look at some of these examples and get a feel for how the algorithm works. So let's look at that first example a little more closely. We want to make sure that in each of our 3 groups that there's an equal number of ones. So how many ones are in this string? In this case, there's 3. So in that case, there has to be 1 1 in each of my 3 groups. So what I want to try to do is I want to try to split my string into 2 groups. So by splitting, I'm really drawing 2 lines like this. 1 line there and 1 line there. So we can think everything to the left of this first line is 1 group. Everything to the right of this other line is the last group, and everything in the middle is my second group. So I have group 1, group 2, and group 3. And notice how they all have an equal number of ones in them. That's what I want. And we want to know how many ways can I draw these lines. So I just drew it one way. I'll draw in yellow now. I drew 1 here and I drew 1 here. Okay, so I'm up to 1. There's 1 way to do it. Another way to do it would be if I were to put 1 and 0 in one group, followed by a 1, and then the 0, 1 in another group. And then there's a second way to do this. The third way would be to do 1 0 in a group again, followed by this 1, and we'll put the 0 in the group there, followed by the 1. Then there's one more way to do this, and that is to have the first one by itself, and then 0 1 0 followed by a 1. So there's 4. There's 4 ways that we can split the string. And remember, splitting is just drawing a vertical line, 2 vertical lines, separating the groups such that there's an even number of ones, or there's an equal number of ones in each group. So that's why, that's kind of the approach we're trying to take, and that's why it works on example 1. But we're going to look at a couple cases now, some easier cases. So here's a case now where the number of ones in the string is not a factor of 3. So that, what I mean by that is we can't choose some number n to multiply by 3 by to get the number of 1. So in this case, there's 2 ones, and if we did 2 mod 3, it would not be equal to 0. And that's problematic. This means there's no solution. There's no solution because we cannot draw 2 lines. We cannot split this string into 3 groups such that the number of ones are equal in each group, because no matter what I do, I'm going to have at least one group with no ones in it, and that's problematic. So if the number of ones is not a factor of 3, there's no solution. A third case you'll see is when you have no ones, and believe it or not, there actually is a solution to this, because I could split here and here, for example. There's 0 ones in each group, so this is a legitimate way we can solve this problem. And there's actually a neat formula when it's this case, and we'll talk about it. I'll say what the formula is. We'll let n be the size of the string, so n in this case would be 4, so it's n minus 1 times n minus 2, and then all of this divided by 2. And why is that the case? Well, if I have 4 characters in my string, how many locations do I have to choose from for my first split? Well, I have 3. I have the spot here, here, and here. So I would have 3 for my first. Then how many do I have for my second? Well, once I choose one of these, I can no longer split there again, so I would have only 2 places to choose from. So we would multiply by 2. But you notice when we do that, we're double counting. We're saying if I were to split here first and then here on the right second, we're counting that as different than if I were to split on the right first and then on the left second. But really, that shouldn't be counted as different. So we've overcounted by a factor of 2. So we divide by 2 at the end. So the answer in this case would be 3. These 2's would just die off. But the general format of this is n minus 1 times n minus 2, all divided by 2. And remember, we divide by 2 because we overcount the number of ways to split. Now, in this case, this is example 4 from the problem. The first thing we want to do is count how many 1's we have. So let's figure that out. Number of 1's equals, I count 6 here. So we check, is it an easy case? Do we have 0 1's? No, we don't. Do we have a non-factor of 3 1's? No, we don't either. It's always good to try to think about those easy cases first to get them out of the way. But in this case, we can't break it up into an easier case, so we just got to go solve it now. So how many 1's per group do we have now? 1's per group. Well, I need to have 3 groups, and I have 6 1's, so I would have 2. I would have 6 divided by 3 for 2. So that means for my first split, I cannot split until I have seen 2 1's. So where this yellow here is now, that's where my first possible split can be. So I have the option to split there, here, here, here as well, but can I split after this? And the answer would be no, because then I would be having 3 1's in my first group and 1 in my second, and that's not allowed. So I have 4 possible splits I can do on for my first split. Let's look at the second split. How many do I have here? Well, I have to have at least 2 1's in my group. So the last possible split I can do, or location for it, is right there. Because that gives me 2 1's in that group. But can I include the next 0? Well, yes, I can. So I could split there. Could I include the next 0? Yes, I can. So I'll split here. Could I split even further? Well, no, I can't, because then I'm having the 1 come into my group. So I have 3 possible splits. And now it really just comes to how many splits did I have for my first split and my second split. And if we multiplied these together, we would get 12. And that ends up being the answer. And this is how this problem works. You count the number of splits that you can do for your first split and then the number for your second, and you multiply those together and get 12. Remember that the answer could be big, so you have to mod it by 10 to the 9th plus 7, but that's okay. As long as you store these numbers as longs, that'll be okay. So the way we can count how many splits we can have per group is the following. We know how many 1's we have per group, and as we're iterating over the string from left to right, we'll want to count how many 1's we've seen. So when we are at the first position, we'll say we've seen 1 1. Great. We really want to, our goal here is 2, so let's just keep going until we hit 2. Okay, I get to this 4th character and it's a 1. So I have now seen 2 1's, and that means that from here on out I can start splitting until I see another 1. So for every character from here on out, I want to keep a tally. So this 0, I'll keep a tally. This 0 and this 0, I'll keep a tally, and I'll also keep a tally for this 1, and that's how I can get the 4. Once I see the third 1, I'll have to keep another tally that I've seen 3. I stop counting. So I consume that 1, this 1 here. In the first 1 in group 2, I would read the 0, I would read this 1, and once I read 4 1s, which is 2 times the number of 1s per group, then I can start counting again. So I would take this 1 as a possible split point, the 0 as a possible split point, the next 0 as a possible split point, and then when I hit another 1, I've now hit 5 total 1s. I have to stop counting. So once I do that, I look and I see, okay, well, I've had 3. So then at the end, I can multiply my 4 times 3 and get 12. So let's look at the code now and see how we can implement this. Okay, so the first thing I want to do is I want to count the number of 1s inside of the string. And I'm going to do this using Java 8 streams because I really like using them. I think it's a clean way to use streams. So chars, and then we'll filter every character such that the character is a 1, and then we will count how many we got. And this actually returns a long, so I have to cast to an int. There's going to be a lot of casting in this problem. So let's handle an easy case. Let's handle if there's not a factor of 3 number of 1s. So if the number of 1s is not a factor of 3, well, then there's no solution, so I can return 0. That was pretty easy. Let's handle the other case. That's pretty easy if there's no 1s in there. So if the number of 1s is 0, well, remember the formula? I'm first going to get the length of the string as a long, so I don't need to do a whole bunch of extra casting. So what I want to do is I want to return the length minus 1 times the length minus 2 divided by 2. And I want to convert this to an int. But we are forgetting one thing. We're forgetting the mod I have to use. So I'm going to declare a mod as a global variable and set it to 10 to the 9th plus 7. So then when I return all of this, I'm going to make sure I'm doing it with a mod. So length minus 1 times length minus 2 divided by 2, and then modding out by that mod. So if none of those if statements are true, that means we have some computation to do. So I want to know how many 1s per group there are. And that's just the number of 1s divided by 3. I also want to keep a counter, so I can count how many 1s I've seen so far. And then finally, we'll keep those 2 longs for how many 1s we can have in our first block and how many we can have in our second block. We're going to end up returning the multiplication of the first block and the second block. But remember, we have to mod by the mod, and we have to cast to an int because these are longs. And we're treating these as longs because the length of the string can be so long that the multiplication will overflow if we stick with integers. But by converting everything to longs, we don't have to worry about overflow. So now let's iterate through our string. All right, so if the letter is a 1, then I have to increment my counter, because I'm wanting to count how many ones I've seen, so I know when I can start counting how many splits per group I can have. So if the count of ones equals the ones per group, that means I can start splitting. I can split one possible more way for my first block. Otherwise, if the count ones, this should actually be counter, sorry about that. If my counter is twice the ones per group, that means I can start splitting for my second block. Just like that. So let's see if I wrote this correctly and get the right answer for the first problem. Looks like it. So let's submit and see if it's right. Yes, success. This was an accepted answer to the problem. Let's talk about the time complexity real quick and the space complexity. So I go through the whole string here to count how many ones there are. That's an O of n operation. These following if statements are both constant operations. Variable declarations are constant. I go through the string another time, but do a bunch of constant operations there. So the total time complexity is O of n, and the space complexity, let's look at that now. Do I declare any data structures? No, I just use some extra variables, so it's actually constant space, O of 1 space. If you have any questions, feel free to comment and I'll get back to you, or if you have any video suggestions, please let me know.